Hi guys, Mr. McIntyre here. Just want to carry on now with similar shapes. I figured it would be wise to do a quick recap of the first video. What we looked at was just a basic introduction to similarity and the impact of a scale factor on similar shapes and how we prove that shapes are similar based on the scale factor, corresponding sides and corresponding angles. So ultimately, what we landed at was this formula for scale factor, and that was scale factor equals new over old. And ultimately, the part that we've introduced is what is that dictates new over old. So the new shape we've said is the shape with an unknown. Okay. So it may be that they ask you to find just a missing side. They may ask you to find X centimeters, A meters, something like that. Ultimately, that's the key part. The new shape or triangle or whatever it may be is the one with the unknown, and therefore the other shape that's given is going to be the old shape. So that's really the critical part of it, that we identify which is the new shape and which is the old shape. The old shape should have both or more than one value in it, or side with a represented value in it, whether it be a length and a breadth, or a height and a length, something like that. So what we had actually gone through is we'd gone through a very quick example on how to do, using scale factor, how to find a missing side, and it was an enlargement. And what I want to do is to use the same example to let us see what happens when it's a reduction. And the good thing about the notes on this would be that you'll be able to see the same example being used, and this one is just the reverse of the first one. Okay, with that in mind, if you have a look this time, we are looking to do the reduction, and you'll see I've highlighted that in red. When you see it in the notes, hopefully you'll see that the little grey box should help you distinguish between the two, because obviously they do look very much alike. So what we've got is the very same example. So and the reason I want to show this is that we know what the answer is going to be from the first example, and there's no harm in actually putting that in there. We know from the first example that that there was 7 centimeters. Okay, because we knew that previously there was a scale factor of 3, and we had 7 times 3, and 5 times 3 was 15. So we are expecting it to be 7, and the answer we get is 7. But to go through the full process as a reduction, you'll get to see it in that in the different form. And the main element that changed here is that the new and the old shapes have switched around. So as you can see, where I've labeled step 1, this time the smaller shape contains the unknown value. So that smaller shape contains the unknown X, and therefore the smaller shape is now the new shape. Okay. And when we come down to the scale factor formula, that's going to reverse some of the values. At the bottom, I see now the 5 centimeter breadth on the new shape corresponds with the 15 centimeter breadth on the old shape, and this time the 21 centimeter corresponds with the X centimeters rather than the 7 centimeters in the previous example. So we'll follow the same formula that we would have used previously, and we've obviously looked at it in the previous slide, and here it's still going to be the scale factor is new over old. I'm more than happy when it comes to doing the working if I see SF equals N over O. That's an absolutely acceptable shorthand to save you writing the words out in full, but for the purpose of the note, it's nice to be clearer. Okay, so we're going to look at scale factor. It was new over old. As I said, the main difference is that now the values are reversed. The new value is going to be from the smaller shape, and the old value from the larger shape. Okay, now that we've looked at that, scale factor is new over old. We know from the shape above the two sides that correspond that are going to allow us to look at a scale factor, or at least calculate a scale factor, are the 5 and the 15. Now we've got the new side is the 5 is the smaller one, and the old is the larger one. So it reverses. You remember we got 3 for the scale factor with the first one because it was 15 over 5. 15 divided by 5 was 3. So what happens this time is that we have 5 over 15. Now, it's absolutely okay to leave 5 over 15 as the scale factor, but at National 5, it's always good practice to simplify the fraction, and particularly with scale factor, make it a lot easier to deal with if we can do that. So obviously, they both divide by 5, so that gives us a scale factor of a third. And I've mentioned before, if the scale factor is less than 1, then it's going to lead to a reduction. We know from the example already that it's definitely a reduction. We know that the shape's getting smaller. We've already seen this. But that's just another example of how we can keep that in mind. And it's something that you want to do a kind of mental check on as you're going through the examples. Okay, therefore, each dimension is going to be reduced by a factor of 3 or multiplied by a third. And that's important. This little grey shaded portion here, this is just to remind you that although we are multiplying by the scale factor, and we're always going to multiply by the scale factor, when you multiply by a number less than 1, then we're going to reduce the value. And in this case, it's the same as dividing by 3. So what we'll do is we'll have a wee recap on how we deal with fractions when we have this situation, and we'll have a look at the diagonal simplification method that we've used at the beginning of the year. But ultimately, this one's quite straightforward because if we're multiplying by a third, we're dividing by 3. Okay, so this time the x can be calculated, as you can see down at the bottom. We've got the x can be calculated. X is the unknown value. We always start with the scale factor times the corresponding side. This time, rather than it being 7 like it was before, it's the 21. So we've got x equals a third times 21, which equals 7. And if we are going to recap on why is it a third times 21 equals 7, then what we can do is we can look at what actually that means. That's a third from the fraction work we've done. That's a third times 21, which is a third times 21. And I've always told you with the whole numbers, think of it as the whole number over 1. If we look for diagonals, we know that the diagonals can both be divided by 3. That becomes 1. That becomes 7. So we're left with 1 times 7 on the top and 1 times 1 on the bottom. So 1 times 7 is 7. 1 times 1 is 1. We divide by 1, we get 7. And that's going to be useful when we get to slightly more complex fractions as a scale factor. That's rules that we've learned previously. It's the difficulty with National 5. You need to retain some of the stuff you've done from previous topics. So the scale factor, what we were expecting, is a third times 21 will give us the answer, 7 for the missing value. We knew that from the first time we'd gone through it. So that's all good. Okay, now let's go through a full example where we start fresh, and I've put a little boxes in here for the purpose of labeling. So to start us off, we want to calculate the missing dimensions in the following similar shapes. So we know they're similar already. That means we can make all the assumptions that we can use the scale factor, and that's important that they mention that they're similar. So we have here 2 triangles. We have one that has the height 5, one that has the base 4, another that has the height A, and another that has the base 16. So straight away, the unknown value is on the right-hand side in the larger triangle. So we can say straight away that's the new shape. That leaves us quite simply with the smaller one as the old shape. And that dictates the formula for the scale factor. We look at the scale factor equals new over old. We want to look in this occasion, we want to look at the 2 corresponding sides to find the scale factor. And the reason we can't do, we can't use 5 and A is we don't have 2 sets of corresponding sides to calculate the scale factor. There has to be 2 sets. So what we've got is we've got 16 and 4 on the new shape. It's 16, so the 16 goes on the top. On the old shape, it's 4. We know that 16 over 4 is a divide, so the scale factor is 4. Nice and straightforward. Now, how do you find the missing dimension? What are we looking for now? We're looking for this value A. So A is therefore the scale factor times by the corresponding side to A. And we've already looked at this before. The corresponding side to A is over on the left-hand side on the smaller old shape. It's 5. So A corresponds with 5, which means it's the 5 that goes into the multiplication. So A equals scale factor times the corresponding side. I'll just put cor side. Or A equals 4 times 5, which equals 20 meters. So the missing side in this example is 20 meters. Does that make sense? We've got a scale factor of 4. Let's just check that. So if we had 5 times 4 is 20, 4 times 4 is 16, and it's an enlargement. The enlargement tells us that we should expect a scale factor that's larger than 1, and that is in fact the case. Example B then, let's just kind of go through what we're expecting. Just looking at this straight away, hopefully you'll recognize we're working from left to right here, and there's a reduction. So in my head, straight away, I'm expecting that the scale factor is going to be less than 1. Okay, it's going to be a fraction that isn't top heavy, and therefore the shape is reduced. What are we looking for in the first instance? We're looking to label the appropriate shape. The new shape is the shape with the unknown value. Where is that? That's over on the right-hand side. So the smaller shape is the new value. The larger shape is the old value. And we can just press on by substituting in the values. Where are the corresponding sides? In this case, the corresponding sides are 18 and 3. We can't look at the 36 and the D just yet. So new shape is 3. Old shape is 18. 3 over 18, we can simplify to 1 over 6, divide the top and the bottom by 3. So our scale factor is 1 over 6, or divide by 6. It's not always going to be that case, but divide by 6. So how do we find the unknown value? We take D equals the scale factor times the corresponding side, and this time the corresponding side is 36. So we've got scale factor times 36, or 1 over 6 times 36. We know that's the same as a division, so that's 36 divided by 6, which is 6 millimeters. Or, as we have done in the past, we have a sixth times 36. We treat that as 36 over 1. Cancel diagonally. We've got 1 and 6. That's going to give us 6 over 1, which is 6. Okay, that's important when we get to questions where we may have a scale factor, and the scale factor could be 2 over 3, in which case when we get to the point where we're going to do the fractions, it gets a little more complex. But in the meantime, nice straightforward 2 examples, scale factor times by the corresponding side, and you'll get the missing value. Right, now what do we do when we have a shape that has a scale factor that may not have a 1 on the top of it? So let's have a look and imagine we had 2 shapes. There was an enlargement. We had shape A and shape B, and the scale factor results in a value something along the lines of 8 over 5. Okay, and if we had an unknown value, we had 20, and we had A centimeters. What would we do if we have a scale factor that doesn't simplify like this? So like I'd said before, we'd still take A as the scale factor times the corresponding side. This time it's 20. Now when we've got a complex set of fractions like that, it's 8 over 5 times 20. We can have a look at it and think of that 20 as 20 over 1. And I mentioned that to you before. And what you can do from our fraction work we've done earlier in the year, we can take the 5 divides by 5, the 20 divides by 5, and therefore what we end up with is 8 times 4 on the top, which is 32. 1 times 1 is 1, and therefore It's 32. So although the scale factors may end up with something that doesn't look so tidy, and it's an 8 over a 5, or indeed a 5 over 8, you don't change the process, just go through the process as you would normally. Remember that you can put a whole number over 1 and look for your diagonal cancellations.